Hello, HalfMike here, and I just wanted to say real quick, if you've been enjoying my content, please remember to subscribe to the channel here on YouTube and follow me on Twitch so you can always catch us when we're live and see more content. Also, if you are new here, welcome in, and if you're enjoying the video, please remember to like it because it helps me out a lot. I also post funny clips and other things on TikTok. All the links are in the description below, and thanks again. Now let's get into the video. Now we have some really exciting news I am hyped to look into. Massive energy beam pointed at Earth appears to break the laws of physics, scientist says. This is a Vice article talking about an energy beam shooting at Earth. I have no idea what it's talking about. I just saw it, looked really interesting. I'm very interested in like physics and quantum physics, stuff like that. Always have been, naturally as a Doctor Who fan. So we're gonna read into a little bit of this. An intense jet energy in space appears to be traveling 7 times faster than the speed of light, a feat that is considered physically impossible in our universe, though this rapid pace is only an optical illusion, according to a new study. It still represents a blast of energy shooting towards us at a very, very nearly the speed of light. Interesting. The Hubble Space Telescope has captured incredible views of the jet, which was ignited by an unprecedented collision between 2 hyperdense objects called neutron stars that led to one of the most important breakthroughs in astronomical history at the time it was discovered in 2017. Okay, Kitty, get down. While the jet did not actually break the cosmic speed limit, it raced right up to the edge of this impassable threshold, reached at least 99.97% of the speed of light, which translates to about 607 million miles per hour. Scientists led by Kunal Muli, an astrologist at the California Institute of Technology, used Hubble and other telescopes to clock the jet's superluminal motion, meaning the trippy illusion of faster than light speed, in a study published on Wednesday in Nature. We have demonstrated in this work that precision astronomy with space-based optical and infrared telescopes is an excellent means of measuring the proper motions of jets in neutron star mergers, Muli and his colleagues said in the study. The James Webb Space Telescope should be able to perform astrometry much better than that with the Hubble Space Telescope, owing to the larger collecting area and smaller pixel size. The crash between these neutron stars was so explosive that it created ripples in the very fabric of space-time known as gravitational waves. Even though the merger happened at a whopping 140 million light years away, scientists were still able to detect these subtle waves when they passed through Earth in August 2017. That is fucking crazy. The event, named Gravitational Wave 170817 after the date it was discovered, quickly earned a monumentous place in space history. For starters, it was the first time that scientists had ever identified waves from a merger between 2 neutron stars. A handful of gravitational waves formed by mergers between black holes had been discovered at that point, but collisions between neutron stars had remained elusive. The nature of the objects is important because the black hole mergers do not produce visible light and can only be spotted through the novel process of gravitational wave astronomy. In contrast, collisions between neutron stars, which are compact, roiling objects formed by the explosive deaths of large stars, do produce luminous blasts of radiation. The possibility of capturing 2 different signals of the same event, in this case with gravitational waves and light signal, can produce a wealth of insights that are impossible to discern from only one observational technique. This is fucking crazy. So it sounds like 2 dying stars were just flying around space and happened to smack into each other and energy shot out. What I can't understand though is why does it look like it's moving faster than the speed of light? And if you can see that, is that not light? This is so weird. For this reason, scientists hustled to get as many telescopes as possible pointed at the sky. Okay. Now, 5 years later, Muli's colleagues have added more detail to this astronomical mosaic with observations from Hubble as well as from the European Space Agency's Gaia Observatory and several radio arrays on Earth involved with the field of very long baseline interferometry. The team was able to see the jet slamming through a blob of material that had been blasted into space from the merger, which accelerated the mass to high speeds. By measuring the motion of the blob, the researchers were able to show that the jet appears to be outpacing the speed of light 7-fold. As far as we know, nothing can travel faster than the speed of light, except for the expansion of the universe itself. The illusory effect of the superluminal motion stems from the ultra-relativistic speed of the jet, which is traveling just slightly slower than the light it emits. Okay. The matter in the jet is just barely trailing its luminous light particles known as photons from our perspective on Earth. Because of this effect, photons that the jet emits in the early phases of its eruption can end up arriving at Earth around the same time as photons emitted at later stages. Holy shit, I understand now. The light from the initial explosion is hitting us just before. That's crazy, because the jet is more or less keeping pace with its own light output. This trippy phenomenon makes it seem as the jet is moving faster than light speed, a result that would shatter our understanding of physics, when in fact the jet is merely moving near light speed. As a result, that is pretty dang mind-boggling. That's fucking crazy. Wow. Our study represents, to our knowledge, the first proper motion constraint on the Lorentz factor, which is a special measurement of moving objects of a gamma ray burst jet indicating ultra-relativistic motion. The researchers said in the study, the combination of optical astrometry and radio VLBI measurements with current observing facilities may be even more powerful and could deliver strong constraints on the viewing angles of neutron star mergers located as far away as 150 megaparsecs, equivalent to nearly 500 million light years. Jesus. As long as they have favorable inclination angles and occur in relatively dense environments compared with GW 170817, the team concluded. That is wild. That is wild, dude. This is just concept art. So this is, wow. That is fucking crazy. If we could find a way to, like, I don't know how much energy is diminished between these two when they collide like this, but if there was a way to, almost like pistons and engine, harness the ability, like keep these two relatively close to each other and in controlled instances have them collide to put out this energy, just think about how much energy that would be. That is wild. That is so wild. All right, one more physics thing. This is actually really new news, really new. I just saw this last night, I think. Looks like it's from 2 days ago. Quantum entanglement has now been directly observed at the macroscopic scale. Quantum entanglement is the idea of two particles being tied together, like mirrored together, and anything that you do or happens to one particle is instantly mimicked on the other one, regardless of where it exists in space-time and where they are relative to each other. It's been a theory for a while. They've been working on it. It would change the way we can share data and store data. Quantum entanglement could allow for internet connectivity anywhere in the universe all at once, in theory, because any data you put in one particle, you can instantly mimic and send to another live in space-time. It's this could change absolutely everything if we get a concrete understanding of it. So this is really exciting. I definitely wanted to see what was going on here. So this looks like is how they're representing two particles that are quantumly entangled in a weird space-time relationship where like there's an unseen tube or connection between the two, and anything that's happening here is also happening here. Quantum entanglement is the binding together of two particles or objects. Even though they may be far apart, their respective properties are linked in a way that's not possible under the rules of classic physics. It's a weird phenomenon that Einstein described as a spooky action at a distance, but its weirdness is what makes it so fascinating to scientists. In a 2021 study, quantum entanglement was directly observed and recorded at the macroscopic scale, a scale much bigger than the subatomic particles normally associated with entanglement. The dimensions involved are still very small from our perspective. The experiments involved two tiny aluminum drums, one fit the width of a human hair. Oh my God. But in the realm of quantum physics, that's absolutely huge. That's insane. If you analyze the position and momentum data for the two drums independently, they each simply look hot. From the National Institute of Standards and Technology in the US last year. But looking at them together, we can see what looks like random motion, and one drum is highly correlated with the other in a way that is only possible through quantum entanglement. While there's nothing to say that quantum entanglement can't happen with macroscopic objects, before this, it was thought that the effects weren't noticeable at larger scales, or perhaps that the macroscopic scale was governed by another set of rules. Interesting. The recent research suggests that that's not the case. In fact, the same quantum rules apply here too, and can actually be seen as well. Researchers vibrated the tiny drum membranes using microwave photons and kept them kept in a synchronized state in terms of their positions and velocities. To prevent outside interference, a common problem with quantum states, the drums were cooled, entangled, and measured in separate stages while inside a cryogenically chilled enclosure. Wow. The states of the drums are then encoded in a reflective microwave field that works in a very similar way to radar. Previous studies had also reported on macroscopic quantum entanglement, but in 2021, research went further. All of the necessary measurements were recorded rather than inferred, and the entanglement was generated in a deterministic, non-random way. Wow. In a related but separate series of experiments, researchers also working with macroscopic drums or oscillators in a state of quantum entanglement have shown how it's possible to measure the position and momentum of the two drumheads at the same time. In our work, the drumheads exhibited a collective quantum motion, said physicist Laure Mercier de Lepine from Aalto University in Finland. Oh, wow, I definitely butchered this name. The drums vibrate in an opposite phase to each other, such that when one of them is in end position of the vibration cycle, the other is in the opposite position at the same time. In this situation, the quantum uncertainty of the drum's motion is canceled if the two drums are treated as one quantum mechanical entity. What makes this headline news is that it gets around Heisenberg's uncertainty principle, the idea that position and momentum can't be perfectly measured at the same time. Interesting. The principle states that recording either measurement will interfere with the other through a process called quantum back action. What's quantum back action? Refers to the effect of detector on measurement. Ideally, a detector should have no influence on the quality it's measuring. However, in quantum systems, it is sometimes the case that the back action by the detector is an inherent feature of the system and not just a result of the detector being imperfect. Back action has important consequences for the measurement process and is a significant factor in measurements near quantum limits, such as measurements approaching standard quantum limit. Sequel. Just kidding, it's not sequel. That was an IT joke. As well as backing up the other study and demonstrating macroscopic quantum entanglement, this particular piece of research uses the entanglement to avoid quantum back action, essentially investigating the line between classic physics, where the uncertainty principle applies, and the quantum physics, where it now appears to. One of the potential future applications of both sets of findings is in quantum networks, being able to manipulate and entangle objects on a macroscopic scale so that they can power next generation communication networks. This is what I was saying at the beginning. If you can write data to one particle and it's instantly mirrored on another particle, you can create a network that we've never seen before in terms of an internet, like a network of data, which is all the internet is. It's a collection of gateways and SCADA and end user devices that all hold data and share the data together. Apart from practical applications, these experiments address how far into macroscopic realm experiments can push the observation as distinctly quantum phenomena. Writer physicists Ho Kwan Lau and Ashish Clerk, who weren't involved in the studies, in a commentary on the research published at the time. Wow. Yeah, so that's huge. That's huge. I'm really excited to see follow-ups on this. Absolutely wild. Space is so rad. I mean, obviously, I'm a huge tech enthusiast, which kind of goes hand in hand with being a sci-fi nerd with VR and stuff. Yeah. Absolutely wild. Thanks for watching, guys. Follow me on Twitch to join us live, like and subscribe, and I will catch you later.